Hi, I'm Gary, and this is episode 264 of EV Musings, a podcast about renewables, electric vehicles, and things that are interesting to electric vehicle owners. And on the show today, we'll be looking at EV battery repairs.
This season of the podcast is sponsored by ZapMap, the go-to app for EV drivers, helping you find and pay for public charging with confidence.
Now, our main topic of discussion today is battery repairs. Long-time listeners will possibly remember Pete Mooney from episode 150, where he came on to chat about his EV6 and what it was like to live with as a vehicle. Now, that was way back in 2022. Since then, he's been merrily putting the miles on to the point where he's done around 100,000 of them at the moment. Now, that's pretty impressive for any car, but it's important in the big scheme of things for electric cars because that's the point at which battery warranties tend to expire. Usually it's 8 years or 100,000 miles, whichever comes first. Naturally, Pete's a little worried about what happens now. But remember, a warranty isn't a lifespan indicator, it's a time limit for covered repairs. All cars have warranties from new. Most are in the 3 to 5 year range, covering parts and often labour for things that go wrong that are not wear and tear. Kia and Hyundai are something of an exception with a 7-year parts and labour warranty covering everything on the car. So let me ask you, when was the last time you had a car that was out of warranty and were really concerned about it? Well, the answer, especially if you don't buy brand new cars, is probably rarely. You know these are cars and things go wrong. If they're covered, somebody else pays to replace them, and if not, you pay to replace. Cam belts, timing belts, cylinder heads, fuel injectors, water pumps, etc. But when it comes to electric vehicles, the big thing that most people worry about and that most anti-EV people pontificate about is the battery. And the reason is that battery packs, especially some of the earlier ones on the Tesla Model S, etc., were very expensive if you had to replace them yourself. As they are the main part of the EV, it stands to reason that people are going to be concerned about them and how long they last. So today, we're looking at batteries. What sort of issues and errors can occur? How often do errors crop up? And does every battery issue mean a complete replacement of the battery unit? Now, I could talk at great length about this and do lots and lots of research and in-depth analysis. But you know me, I'm basically lazy, so I thought the easiest thing to do would be to get somebody on who actually knows what they're talking about and ask them the questions instead.
Hello, I'm Sara Ridley. I work for Autocraft Solutions Group and I'm the Engineering and Quality Director there.
Fantastic.
We're engine remanufacturers and battery remanufacturers for EV vehicles.
What's your EV story? How did Dr. Sara Ridley come to the world of electric vehicles? I assume you drive electric.
I drive a hybrid actually at the moment. But yes, well, I started off with engines, as most people do, and I started off in remanufacturing. So remanufacturing basically takes things at the end of their lives and gives them new lives. And we've been doing that with conventional engines for years and years and years. And it's a huge passion of mine because things come in broken and they go out completely useful again and back to the standard they should be. And we realised probably 10 years ago that EVs were starting to come in, and we started very slowly with a few government programmes like the Faraday Challenge with very small battery packs. But it snowballed, and we realised probably about 5 years ago that actually if the world is transitioning to EV, they're going to need solutions for them because, as with all things, the second-hand market is what drives everything. And that's having confidence that what you have can be as easily repaired, as easily looked after, as easily gives you the same sort of life, drives the second-hand market, which drives the new market, which helps us to transition. And I think we all agree that transitioning to EV is the most important thing we can do at the moment for the planet. It might not be perfect forever, but that's really good now.
So let's talk a little bit about EV batteries. And let's start by, can you address the big bit of misinformation that a lot of non-EV drivers and some EV drivers have probably heard, which is your EV battery is the same as your iPhone. It'll last about 3 years before being useless. So if someone says that to you, how do you tend to respond?
In the sense that it uses the same technology, I understand where they're coming from. The reality is that in most people's experience, an EV battery will last without much need for any kind of intervention for about 8 years. There's widely published statistics on that. Equally, we know that at the moment the failure rate is slightly higher. It's about 0.5%. So that's higher than you will get with internal combustion engines, but realistically they've been around for 100 more years, so we would expect them to be more stable. However, we do know that in the vast majority of cases where batteries do start to fail a bit earlier, you can do something about it. You can repair them. You can get proper testing, you can get a proper repair, and it will carry on lasting. And the bonus of an EV battery, in many ways, actually, over and above an iPhone battery, and that's largely about economics, is if you look at your phone battery, it's very tiny. It uses the same technology, but very tiny. And it's a battery, a cell normally. However, an EV battery is made up of lots of cells and modules, and they can be individually replaced in many instances, and that gives you a much longer life and a much more economical state of repair. So yes, there are failures, but there are failures in every kind of transportation. They're not massive. It's unlucky if you get one. I wouldn't argue that one, but you can do a lot about them. So for me, that's not a barrier.
I'm going to come on a little bit about the failure rate in a second, but just sort of a little bit of anecdotal. I've had electric vehicles for 7 or 8 years now, and they've all been bought or leased from new. Other than the one I'm currently in, which I picked up a couple of weeks ago, and that's a used electric vehicle. It's not saying high mileage, but it's 55,000 miles already and it's about 5 years old. But of course, the first thing I did when I went to buy it is I got a battery health check, and it came out at 92%, which I'm quite comfortable with that. Are you able to talk a little bit about battery health checks? How useful are they? How accurate can they be?
The reality is it does depend on the technology used to do the check. So we have found in our experience that the simple checks that are done through the battery management system often are not overly accurate. That's partly because they're a snapshot in time. So a lot of battery checks are effectively static checks. It tells you what the health of your battery is at that point. What it doesn't tell you is how your battery reacts over a period of events, so charging and discharging cycles. So what we would call active testing rather than passive testing. And that's really important because that sets the profile for how well it will hold the charge. So it might have been very well charged and holding at that point, but actually if it's been overly used, so we find that very fast charging and discharging, so rapid charging and discharging, affect the health of the battery over a period of time. So after 5 years, yours has obviously been very well looked after. If it's got 92% state of health, that's really good. But some of them actually degrade further than that. So a very good test can not only tell you what your state of health is now, but it will also predict what's likely to fail over a relatively short period of time. And that's really useful, particularly with a second-hand car, because it gives you an idea about what sort of longevity you're going to get, where your range is likely to be, and also, if you had those bits repaired, where your range would be. So that's really, really important. So there are some quite superficial checks that will give you a snapshot, but we would always recommend an active test because that will give you a much more comprehensive picture.
Would you feel comfortable naming the kind of companies that provide the tests, the active tests that you're talking about?
I can't honestly sit here and recommend one. We don't deal directly with the general public at this point. We work through partners, mostly OEM partners, both battery and vehicle OEMs. However, we have found that most of the tests that we have tried are not particularly comprehensive. So I couldn't honestly sit here and say to you, I could definitely recommend one. And I really don't want to mislead you.
Fair enough. One of the things that, I don't know whether it's anecdotal or not, is that when we're looking at battery tests, one of the things that can quote unquote skew the state of health is that there are the buffers at the top and the bottom of a battery to protect it. There are certain vehicles which will sort of release a little bit of that buffer as the degradation occurs. So it gives not necessarily a false reading, but one that may not be as accurate as it could be. Is that an accurate statement?
Yes, it is. We do know that there are some manufacturers that protect their batteries. What I would say to you, though, is that the most efficient way and the most way for it to last longer is to keep your battery somewhere between about 35% and about 70% charged at any one time. And that's honestly exactly the same for your phone. Charging it all the way up and discharging it virtually all the way down and not healthy for the battery. So part of that will be to protect your battery health and keep it lasting as long as possible. So yes, it is slightly slewed, but the reality is that we can accurately check where a battery should be against the amount of miles it's done and its age. So we understand where that level should be. And actually all that the manufacturer is doing by releasing some at either end of that scale is protecting you and keeping your battery lasting for a lot longer.
A big fear that a lot of people have, particularly ones who don't drive electric or are brand new to electric, is that their EV will stop one day because the battery has died. Now, I'm holding up, for the people who are listening and not watching, I'm holding up a standard 9-volt square battery, which, you know, I've been using these for decades. I've never had one of these quote unquote die on me. I've had one where it's run out of charge. I've had one where I've left it in a device and it's crusted over and corroded at the top and stopped working. But I've never actually had the battery itself die. So when somebody says, oh, well, my EV battery has died, what exactly are they talking about? What's the actual mechanism that's occurring there?
So there are two things. So one, it will have, in the same way as a conventionally powered vehicle will have, effectively a limp mode. So you're getting close, so it will restrict you, and that won't allow you to put your foot down and go really fast and rapidly discharge it. And the idea is it's to get you to a safe location to recharge. So that's technology that's not actually in the battery, but in the management system. And that's the same in any management system. You'll have that in any kind of vehicle. Typically, it's very unusual for a whole pack to fail. But typically if it does, it's likely to be something like a broken connection. So they tend to be wired in series and in parallel. So it's more likely to be a mechanical fault than a battery fault in terms of the actual reaction of the battery. We very, very rarely see one. I can't say that there's never been one. We do see occasional faults in terms of the connections and things like that, as well as just with an EV battery, because as you know, it's a chemical reaction from the moment it's made. And whilst they are made in the same place at the same time, it's like anything else, there is variation. So you get variation in the way they react. Typically, they're the biggest amount of failures. You do sometimes see them in the connections and things like that, but we don't see very many of those. So typically, batteries are very well made.
We've talked about the buffer and the bottom buffer. Have we ever had instances, or are you ever aware of instances, where people have managed to run that buffer so low that it has physically got to the point where they've run so much charge out, there's no buffer left, and it has destroyed the battery from that point of view?
We've never come across an instance of that, no. Not with our customers.
Fair enough. Now, in reality, I know you quoted a stat a little bit earlier, but in reality, how often should an error or fault mean that a brand new battery is required versus the change of a cell or a bit of a pack or the BMS or something other than the actual battery itself?
So this is one of those really interesting things. It's a little bit like Trigger's broom. You can replace the handle, you can replace the head, and you can keep it going. And in theory, an EV pack is exactly the same. So you can replace anything in it multiple times. Now, we know in practice that once it gets below, and this does vary a bit with manufacturer, but about 75% of its overall ability to hold a charge and to deliver that properly, then it typically isn't suitable for EV use. So for a vehicle, we would want it to be above that. So it does vary slightly manufacturer to manufacturer, but that's a rule of thumb, I would say, about there. Realistically, we can replace any of those parts all the way up to there. But at that point, it's still got a very useful life. And that useful life can be as secondary storage. It can be to help balance the grid. We can even use them to power charging stations, because you trickle charge the battery pack, which gives you a quicker charge, and then it trickle charges back again, or you can do it via things like solar panels, wind power, anything like that. So in theory, you wouldn't need a new pack in that vehicle until you got down below that. Now, we do know that packs are replaced more often, and sometimes that's because of the availability of repair and the availability of packs. And part of that is because the technology is growing so rapidly that chemistry changes, and so it's literally about how do we use those to make sure we can continue with those batteries and keep those batteries going. You know, you said your car, the one that you're currently driving, is about 5 years old. I would be willing to bet that the chemistry has moved on in the same model of vehicle considerably. And so it's, for me, the only thing that's a barrier to us being able to repair that is where do we get the replacement cells or modules, because typically that's what it is. And we harvest them. So what we've found over our experience is that 92%, roughly, 92 to 94% of any failed pack is fine, really good, absolutely fit for use. And it's only one or two modules or cells that's the problem. Now, I talk about modules or cells because that comes down to pack architecture. We can do the testing to cell level, we can replace at cell level, but if the pack architecture means we have to take a whole module, not a cell, because we'll break it otherwise, then you have to change a module. So what we actually do is we harvest the 92% that are good. We test them, we grade them, we put them on the shelf, and then we can use those to repair and replace other packs, which means that we can keep them going for a lot longer, and that's really, really important. I worry very greatly that we're leaping straight towards recycling. Now, don't get me wrong, recycling is brilliant, we all recycle, and it's the right thing to do, but it's premature recycling in terms of packs, because they can have so much more life. The EV process for building one means that all of the damage to the environment is up front. All of the emissions, all of those things are up front. Now, we know by the time it gets to about the sort of age yours is and about that sort of mileage, it's paid off its debt, it becomes neutral. But if we can then extend it for another 5 to 8 years, actually it becomes positive. And that's the really big thing. And if we do it with harvested modules, it becomes even more positive. And that's how we're going to get towards that whole carbon neutral, non-damaging thing for me. So it's about maintaining that level of change.
So many questions have come out of that, which
Sorry.
is no, that's fine. We had Stephen Williams, who works with the EV insurance industry, on the podcast last season, and he was talking about the fact that one of the reasons why EV premiums are so high is because there are, and you touched on it there, is that there are many repairers who, they look at a battery, they see there's an issue with the battery, and they don't want to repair it. They want to replace it. So, of course, rather than having to take out a cell or a module and whatever that cost is going to be, they're going to say, no, we're going to take out the whole battery and replace with a brand new one. How much of that do you believe is a result of the fact that it's something completely unknown and it's easier to do that versus, well, actually, there's an education aspect. There's companies like yourself that need to be out there working with the insurance companies and saying, look, we can do quote unquote cheaper repairs at the cell or the module level rather than doing a full battery replacement?
I think actually it's a bit of both. Now, I think the education's getting better. We're getting more and more technicians qualified to remove batteries and do those things. But actual repair is quite in infancy. There aren't that many companies doing it, and it's about people knowing about it. We are starting to get some interest from insurers because we do understand it, and part of it's fear of the unknown. They are high voltage, they are dangerous, not where they're in the vehicle, but when they are taken out and when their lids come off, they are very dangerous. So the first thing we do when we get a pack in is we put it through our initial testing, which not only checks to see, is it damaged in any way, but brings it down to a safe state of charge. So roughly 20%, 20 to 30%. Again, it slightly depends on the size of the battery and things like that, but we bring it down. And that's so we know that it's a safe point. You can't really bring it down to zero because a chemical reaction doesn't just stop. But what we have to do is bring it down to where it's safe. And we can actually do that by going out. So we have mobile units that can go out and make batteries safe. And that's really important for us because when we're transporting them around, once you take it out of the car, it becomes dangerous goods and you have to be really careful about transporting it. And that, to be honest, and that adds to the cost. When you think for an average EV, the cost of the battery is about 40% of the cost of the vehicle. Replacing it's very, very expensive. So I think the lack of people who are qualified to deal with them, the lack of awareness that they can be repaired and that actually repairs can be very cost effective. It varies depending on what's needed, but certainly up to about 50% of the cost of a pack you can save, if not a little more. I'd say that it does vary a lot depending on what's wrong. I couldn't give you an absolute figure. And it also depends a little bit on the architecture of the pack. We know with some packs, they are flooded with resin. So we would call it potted or glue in some way. That makes it very difficult for them to be changed out. But a lot of packs are made on a modular level and on a cell level. And so provided they can be replaced, they can be repaired really easily. They really can. And I think that that's the thing here is if we can get the message out there, if we can work with enough people to say, you can repair this, it's cost effective, you could get an independent test done that will give you a good idea of where it is. Because let's be honest, I've been in automotive for a lot of years now, and I can go out and I can look at a second-hand internally combustion engine powered car with reasonable certainty. I can drive it. I was out with my son at the weekend looking at some with one of my sons because he wants a new car. And we were looking at some second-hand cars. And I can be really, fairly certain. I'm working an EV. I could get into an EV car at a dealer's and I wouldn't know. I really wouldn't. Because there's nothing to see, there's nothing to hear. You need a proper check. And I think if we can get all those things in place, and not just in terms of the general public, but in terms of dealers, independent garages, insurers, actually it starts to become a real snowball. And that'll help everybody. It really does help it going forwards.
Now, the other thing that you mentioned earlier on was the concept of harvesting. So taking a battery that's probably not 100%, taking a battery...
We dismantle it. We literally take it apart.
Okay, and then you'll take out the cells and the modules that are good, and you'll trash the rest. Now, you did also mention that potentially the chemistry of the battery that's in my vehicle will not necessarily be the same as the chemistry in the battery of the same vehicle that is brand new. What's to stop? I think I know the answer, but I'll ask the question anyway. Could you take harvested batteries, cells from a new battery, and put them in and replace a fraction of the cells in my battery, even though the chemistry is slightly different?
No, it's not generally, we wouldn't generally do that. That's not really safe. The battery is set up to work in a very specific way, and it's managed in a very specific way. In the same way as I couldn't put a brand new module or cell of the same chemistry into a battery pack without first balancing it to the profile of the pack. Because what you actually do is you create an imbalance, and that's where you get things like damage to the packs from things like thermal runaway. You create an imbalance. So all we do, we try to keep it as balanced as possible. That makes it more efficient. It also makes it safer for everybody.
Can you go through a little bit the actual testing process that you go through? Why is it not possible, or why is it not just as simple as looking at the BMS and saying, right, that's what the BMS says the issue is, therefore that's what the issue is? Why is it a little bit more complex than that?
Because I always think them as living organisms because of the chemical reaction, because that's essentially what they are. They are a dynamic. What the state of health does if you plug into the BMS is it gives you this is what I'm doing now. Now, typically that's done when it's static, it's been sat for a while, it's in a sort of garage type location, and you plug in and it will tell you what's happening now, which is that they are just resting and ticking over with their chemical reactions. Now, it might well tell you that it's only at 90% or it's at whatever percent, but it won't actually give you a whole picture of how it behaves. Because when you excite those cells, which you do when you are discharging or when you're charging, they behave very differently. And what we need to understand is what's the lowest performing of those cells, because that's where your actual overall performance will be. When it's resting and sat, you'll get an overall picture of the whole of the battery. Once you start to excite those cells, and once you start to charge and discharge them and put them through those cycles, what you actually see is individually what are they doing. And when you can see individually what they're doing, you can understand what the actual overall picture is. You can also see if there are any disconnections effectively. So if there is a connector issue, you'll be able to see that because there'll be a part of it that isn't performing as well, and you'll be able to spot that. And you can also see not only where they are currently but where they're moving to and from, and that's really important again for the overall health of the life. If you think about it as a sort of a range, so it will sit within that range, but once you start to discharge, it will move between that. And what you want to understand is, are they all the same, or have you got one that's down here? Because if you've got one that's down here, that's what will affect the overall operation of the pack as opposed to its resting state.
Now, a lot of people who will either be watching this or listening to this will have potentially researched on YouTube, and they will have seen people like Jonathan Porterfield and Andrew Till plugging in ODB connectors into the vehicle and using something like Leaf Spy or equivalent to look at the state of the cells. Is it as simple as that? Is that what you're talking about? Or is it something sort of a level above that?
So we do that in part as well, but we have other tests as well that we do, and they're designed to understand not only whether we've got that going, but whether we can see any lithium that's shifting, so whether we're going to get any plating in terms of anodes and cathodes, whether we can see any degradation and things like that. There's a whole suite of testing that we do, which is all patented because it runs in a specific way to give us a comprehensive report. So some of the tests are out there, some of the bits of testing that we do you can see in other places, but the overall suite and the way we run it is actually what gives us the comprehensive view of it.
Okay. Now, I realise we've been talking for 25 minutes and we've talked about cells and modules and batteries. We haven't actually done a definition of what's the cell, what's the module, and how does that put together? Can you give us the battery 101 on that, please?
Well, I always think of it, this is a really old-fashioned view, but I'm going to tell you it anyway, it's probably to do with my age, is when you go into an airport and into duty-free, certainly before, nowadays I think they're all curtained away, you see cartons of cigarettes to bring home, sort of in shrink wrapped into packs. So if you think about one of those cartons as an EV battery, each one of those packs inside it is essentially a module, and each of the cigarettes inside the pack is a cell. Now, that's the easiest. I always think that's a really easy way of visualising it, because I think we've all seen them, you know. Sometimes they are arranged just like that. So there are cells inside the modules are then built into the battery pack. That battery pack is then built into the vehicle. That way, if they are welded or attached mechanically in some way to each module, you can replace at cell level. You can see what's happening at cell level, you can replace at cell level. Or if they are potted, so in other words, glued in some form with resin or with a glue of some kind, you might have to replace a whole module. But typically, you can have up to 30 or 40 of those in a pack. So it's only a portion of the pack that's being changed at any one time. We are seeing more and more packs where it is just cells into the whole pack itself.
Mm-hmm.
Those ones, it depends again. Is it put in with resin? Because they're much more difficult to do without breaking all the architecture around them. Or is there a weld or a mechanical fixing in some way? Those ones, again, relatively easy to change.
Is cell replacement or module replacement possible on all electric vehicles? For instance, I know that Tesla use batteries as they're integrated into the chassis on some of the Model 3s and Model Ys. Is that an issue?
Yes, it can be. So the way we work with a lot of our OEMs is it works in exactly the same way as if you take your car to the dealer and you need a new wing mirror. The dealer orders one gets delivered, they change it out and they do whatever they need to do with the one they've taken off. So typically what will happen with our OEM customers is their dealers will go onto their portal, they'll say I have this battery, and they'll do it by serial number because then we know all about it, and that links into our portal. They will order one of the same sort of battery, we will dispatch that to them, so it will be the same state of health, with the same chemistry, the same battery type, again by serial number, so we have a traceability all the way through of everything that happens, including by serial number the bits we take out and replace, so what goes in and what goes out and what happens to it afterwards of each of those cells or modules. We will send that out to them with the packaging and all the paperwork for the old battery. They'll replace it, they'll give us back the old one, we'll repair that and put that back on the shelf. So that makes it a really slick process. Now, where you've got things that are built into the chassis, depending on, again, and it does depend on how it's been put onto the chassis, yes, it could be repaired. The problem is I'd need the whole vehicle because we've got to basically dismantle it in order to get to it. And that is the problem. So one of the things we work very closely with our vehicle OEM manufacturers on how they are developing their new vehicles. Because as an EV driver, the last thing you want to do is have to give up your entire vehicle for quite a while to have somebody dismantle it completely in order to get to the chassis and to the pack, whereas some of the more easily repaired ones, and certainly with some of Tesla's rivals, you remove the whole battery pack, you replace the whole battery pack. Again, it can be with a repaired one, it doesn't have to be a brand new one, but one that works in the same way, that's the same age and the same mileage. We balance all that out, and then it's a much slicker process. The garage maybe only has it for a day or two, which is no real different for you having a vehicle change or a part change, on a conventional vehicle.
And there is presumably a cost implication for taking something in and having to take the whole vehicle apart to get the battery
Huge.
right.
I mean, and this is the problem, is that then makes it much more expensive. It also, and I do think this is really important, for me this is really important, I don't have skin in the game direct to customers, because we don't deal directly with customers, the end users. So for me, it's not, I've got no real skin in the game of that. But the reality for me is, if we don't allow independent garages as well as dealers to be able to do these things, then there's an awful lot of people who will be disenfranchised. And we can't afford to do that. We really can't. You know, it's if you take your always, you know, if you change your car every 3 years, you take it to the main dealers to have the servicing done, then actually probably it's not such a big deal. It'll be very expensive, but it's not such a big deal. But if, like the majority of people, you buy a second-hand car, you take it to an independent garage to do that, actually we're disenfranchising all of those people, because what we're saying is only Tesla people in this case, or only that OEM's people can do it, only their dealers. It's going to cost an awful lot of money. And were I looking at a second-hand one, I'd be thinking, if I buy that, I could be opening myself to a world of pain. And the reality is that most people don't buy a new car every year. Most people want to be responsible environmentally. They want things to be really, you know, they want to be doing the right thing. And we're not allowing them to unless we open that up. So for me, the way we build our EV vehicles is hugely important. And that's why we work both with our battery OEM customers and with our vehicle OEM customers to try and make sure we can keep that going.
We've talked a lot about repairing cells and repairing modules, repairing the battery, the actual physical hardware itself. From your experience and the work that you're doing for the OEMs and the battery manufacturers, how much of the repairs and the work that you're doing are actually battery issues, and how much are things like, I'm going to say battery adjacent, so damage or corrosion to HV cables or water ingress or things like that? Or do you just deal with the batteries themselves?
No, we do see both. We do see other things. We don't see very much in terms of the cabling and things like that. That does tend to be fairly secure. We've seen the odd one with things like water ingress, that kind of thing. But generally speaking, the majority of issues that we are seeing are battery related, either to do with the way it's been put together, so things being loose or connectors coming loose or being damaged, or with the actual battery chemistry itself. But again, like I said to you before, over 90% of the battery, even when we see faults, is fine. And I think that's something to hold on to, is that there might be a fault, but it is only a very small proportion of the whole pack.
Do you have stats about the percentage of issues related to different battery chemistries? Because I mean, there are a number out there, but the two main ones are your NMC and LFP. Do one of those?
We don't see a lot of. So I hate the phrase digital twin, because it's not really right. But we have profiles for each different type of chemistry that we deal with, because obviously they do behave differently, and we can't compare them directly. Although actually, I have to say, we don't see a great deal of difference in terms of the return rates or the need for repair rates between any one chemistry. It feels to us at the moment, and we've only had, in terms of actually repairing batteries on a production economic scale, we did a lot before. We've done a lot of small runs, but in terms of actually for production, we're only talking 2.5 to 3 years worth of data. Actually, there's not a lot of difference. So I couldn't sit here and say to you one chemistry is definitely better than the other, because we don't see a great deal of difference in those sorts of rates.
But the flip side to that is you can't turn around and say one chemistry is definitely worse than the others.
No, and it's true. And to be honest, I wouldn't let that necessarily concern me as a consumer. I think for me, it's about, have you got a repair scheme within your dealership or within the OEM group that means if I have something wrong, you can deal with it, or you can point me to the place that can deal with it. Because the last thing I want is to buy one where I know I've got no hope of repairing it. Because whilst it might only be a small chance of it going wrong, you know, the sort of 0.5%, do you want to be that one person? Definitely not.
Oh, absolutely. Now, I want to talk a little bit more about the actual repair ecosystem, because you've mentioned it a number of times on the discussion already. You don't deal with the actual drivers themselves.
No.
You're at a different end of the process. So if, God forbid, I have an issue with my 5-year-old EV and I want it to be fixed, what's the process for getting it to you or someone like you? What is that ecosystem at the moment?
At the moment, the way it works is, because we are not in independent dealers at this point, the way it works currently is you would go to that OEM and say, do you have a repairer? And they will normally process that for you. You will go via your local dealer's portal to us, and that's how it will be affected, and it'd have to go through them. I say what we are now very much interested in and trying to work towards is proliferating that kind of technology and that kind of repair system. It's twofold really. One, you get that confidence up, and if we get the confidence up and we help people to do it, we see more repairs, we see more business. That's the reality. But we also see more call coming back to us, because obviously we want the ones back so that we can repair them, which means we've then got an offering to give back out. That's really important for everybody because it keeps the whole flow going. But also it then means if we get into places like independent dealers, if we have a system for doing that, then actually the EV park automatically becomes bigger because people are confident to buy one at second hand. They are confident to go out there and change from what they're currently driving to a new type of technology. And that's important for all of us.
Oh, 100%, 100%. Going back to earlier on, if we say a battery is at 75% state of health, does that mean that every cell in that battery is at 75% state of health? Or does that mean that 25% of the cells in that battery are at 0 state of health and the rest are at 100? Or does it sort of mix and match?
No, typically, and again, it will depend a little bit on the test that you do. Okay, so if you're looking at the BMS, it will give you an overall. So that will be a kind of effectively average. So unlikely to have any at 100%, you're unlikely to have any at 0, but it'll be a sort of average. If you're running a test like we run, then that will be the worst performing cells in the battery. Because because they are wired in series and then in parallel, your overall battery performance is typically at the lowest performing member.
Right.
And that would be the lowest performing cell or module. So that would be what we would report.
Let's move on to skills and skills deficit. We've talked a little bit about this already. Do we have enough people with the right skills and equipment in this country to be able to do the kind of things that you and your organisation are doing?
Well, the simple answer is no. That's the reality. So things are getting better in the sense that there is starting to be good technician qualifications for people to remove batteries, to make them safe, to replace batteries. In terms of actually the proliferation of the technology and the skills to be able to repair them, then no, there isn't. It is that simple. There are only 1 or 2 players in the market, and they are not in all places. And it takes us a while to be able to train people to be able to get our technology over there. We're privately owned, so that automatically limits a little bit what you can do in terms of, where are we going to find the money to invest. So we typically partner, and we partner with OEMs because that makes sense for us. And then we have the backing, and it gives them the infrastructure they need, but it gives us that level of security, if you like. But no, there are very few players in the repair market, and that's a real shame. That said, I do think that it will come. We're not the only people looking at this. We have a really good solution here and now. We want to be out there and telling people. There will be others. People are already there and in the market, so we do know it can be done. The biggest issue is making sure that what's done is done competently, because that, again, to me, is about confidence. And we are really proud to say that of all the ones that we have repaired, we haven't had any warranty claims on those ones that we have repaired. So we know everything we put out is good.
Good.
However, I can't say that about everybody because I don't know. But we have to get to the point where we have that level of technology for everybody.
When it comes to upskilling people, there are 2 ways of doing this. And you've already mentioned one, which is you bring people into your organisation, you train them internally, you give them all the skills that they need. And that's absolutely fine, and that's what a lot of companies do. But of course, you've then got the other aspect of this, which is there needs to be an education aspect at technical colleges or for younger people to actually learn that kind of skills and experience, so that when they come to you, they have a level of knowledge, a base level that you can build on. Are you doing any work to try and improve the education level for people before they come into your organisation?
So we're partnering with a couple of local colleges and one UTC near us to try and get that started, but it is in its infancy. And for us, this is about how do we start that? Again, we are a relatively small organisation. There is about $500 in total, and not all doing EV. It would be, unfair of me to say we are, and we aren't. Yes, so we're poking with local ones, but we do need a more general thing. But again, this to me comes down to that recognition that this is what we need to do. So what I see coming out in current legislation, what I see coming out from the government, and even when we are talking about the path to net zero, it's all about recycling. It's not about repair. That middle part of reuse and repair is very, at the moment, undervalued and underseen. And until we make that step change, I spend a lot of time talking to people, lobbying for it, because I am, very, very passionate that this is what we need to do. I really do think that. But until we get to that point, you only get pockets of recognition. So because we take apprentices, because we take work placements, because we engage with our local UTCs, our local colleges, we have some leverage and some say with what they do, and they can see that there's a need and they can start to help us develop that. But it's getting it to the more wide and mainstream that's the really big challenge. And that will come, I think, a little from OEMs because they are engaged. But again, we do, I'm afraid, still from some OEMs see our batteries won't ever fail. And if they do, we don't want anybody to know. And the reality is, like it or not, they will. But things do. That's okay. I tell all my apprentices the only people who don't make mistakes are the ones who aren't doing anything. And it's no different with batteries and with cars, is it? The ones that don't fail are the ones in the garage.
We've come to the end of our time, Sarah. Is there anything else you want to say on this topic before we finish?
The only thing for me here is that to replace an EV battery before it needs to be replaced, so in other words, by not repairing it, by not keeping going for the longest, is madness. It's madness in terms of cost. It's madness in terms of the environment. Repairs are a fraction, less than 5% of the overall impact of a battery. In environmental sense, it makes no sense not to do it. And the more I can get the message out there, the more people who know about it, the more we move towards that, the better for me.
Dr. Sara Ridley, I appreciate your time. Thank you very much for coming on the show.
No, thank you, Gary. It's been an absolute pleasure.
A couple of takeaways from this. Battery issues and problems will occur with some electric vehicles, and that's one reason manufacturers provide warranties to help new owners deal with it. The figure that Sarah quoted was about 0.5%, which is slightly higher than the equivalent for internal combustion engine vehicles. But as Sarah said, they've had 100 years to sort out the tech, so you'd expect engines to be in a much better state than batteries at this point. But what Sarah was at pains to point out is that just because a battery pack has a problem, it doesn't mean that the battery needs to be scrapped and replaced at huge cost to the owner. With the work that Sara and Autocraft Solutions do, it's now possible to bring the car in, identify which part of the battery has the issue, isolate it, replace it, and send it back out as new. That's both quicker and cheaper than replacing it with a brand new battery. The other thing that's apparent from this discussion is that there is at present a bit of a tendency to take faulty batteries out and send them straight to recycling. Whilst there's nothing intrinsically wrong with that, it does miss out on a great deal of useful life, where a battery which is no longer suitable for use in an EV can go on to home storage, or as Sarah suggested, battery storage for EV chargers, for example, which could be trickle charged from low voltage grid connections, but still used to rapid charge EVs. Now, I don't know about you, but I thought this was a fantastic discussion, and I love Sarah's duty-free cigarettes analogy to explain cells, modules, and packs. It was brilliant. So, having listened to this, do battery issues still loom large for you as potential EV owners? Or are you an existing EV owner who's approaching the end of your EV's battery warranty? Do you feel concerned? I certainly feel a lot more relaxed about the state of the battery in the vehicle that I've just bought. So let me know, info@evmusings.com. It's time for a cool EV or renewable thing to share with you listeners. Keeping with the battery theme, I want to talk about a new battery install for energy storage. Construction's recently started on the 100 megawatt Meredin, the 100 megawatt Meredin big battery in Western Australia, which is set to finish in October 2026. This battery is going to help stabilise the power grid and support clean energy in the Wheat Belt and Eastern Goldfield regions. The project will create jobs and provide benefits to the local community during its operation. Now, this battery joins nearly 500 megawatts worth of mostly 4-hour battery storage operating in the Southwest Interconnected System since 2023, and ahead of a further 700 and 28 megawatts of committed storage that's expected to be brought online in the next 18 months. Batteries for the win, right?
The EV Musings podcast is sponsored by ZapMap, the go-to app for EV drivers, helping you find and pay for public charging with confidence. See what charge points are available right now with live availability and unrivaled UK charge point coverage at your fingertips. Pay at thousands of charge points within the app or with the ZapMap charging card. Join over 1 million EV drivers, download ZapMap and charge with confidence.
I hope you enjoyed listening to today's show. It was put together this week with the help of Dr. Sara Ridley and Pete Mooney. Many thanks to them for their help. If you have any thoughts, comments, criticisms or other general messages to pass on to me, I can be reached at info@evmusings.com. On the socials, I'm on Blue Sky at evmusings.bsky.social. I'm also on Instagram at evmusings, where I post short videos and podcast extracts regularly. Why not follow me there? Thanks to everyone who supports me through Patreon on a monthly basis and through coffee.com on an ad hoc one. If you enjoyed this episode, why not buy me a coffee? Go to coffee.com/evmusings and you can do just that. ko-fi.com/evmusings. And it takes Apple Pay too. Regular listeners will know about my 2 ebooks, So You've Gone Electric and So You've Gone Renewable. They're 99p each or equivalent, and you can get them on Amazon. Check out the links in the show notes for more information, as well as a link to my regular EV Musings newsletter and associated articles. I know you're probably driving or walking or jogging now, but if you can remember and you enjoy this episode, drop a review in iTunes, please. It really helps me out. Thanks. If you've reached this part of the podcast and are still listening, thank you. Why not let me know you've got to this point by messaging me at musingsev.bsky.social with the words, "Can you get me 60 kilowatt hours at duty free, please?" Hashtag if you know, nothing else. Thanks as always to my co-founder Simon. He posted an Instagram reel from a museum he went to in Italy recently. It was devoted to household appliances through the ages. He was particularly interested in the small device that was an apparent forerunner to the modern-day vacuum. But manual, of course. He said,
So this is one of those really interesting things. It's a little bit like Trigger's broom.
Thanks for listening. Bye.